The first two sections of this chapter talk about applying properties of real numbers and evaluating and simplifying expressions. First, we're going to talk about what a real number is. A real number consists of both rational and irrational numbers. So real numbers are split up into two sections, rational, irrational. So before I list some examples, I want to give some properties here at the bottom of what a rational number is and irrational numbers. And I would go ahead and draw this diagram in your notes because I think it'll be pretty useful. So first, a rational number is a number that can be written as a fraction or written as a decimal that terminates or repeats. So for example, rational numbers, I'm going to put in this little bubble right here, would be any fraction, so like 3/4, which as a decimal is 0.75, or a negative fraction, -1/3, which as a decimal is 0.333, and this is repeating. So it can be written as a fraction or a decimal that repeats, doesn't matter, that's a rational number. So an irrational number cannot be written as a fraction, and cannot be written as a decimal, that terminates or repeats. So it's something that goes on forever and ever and ever. For example, the square root of 2. That's approximately 1.4142213. It just goes on forever and ever and ever. It cannot be made into a fraction. Or if you had a negative square root of 14, that's approximately -3.74165. I mean, you get the idea, it just goes on forever. Or pi. We know that pi is approximately 3.14159, and that goes on forever and ever and ever. So that is also an irrational number. So two sections, rational, irrational. Inside the rational, there are a couple subcategories. First, we have the integers, and integers are any positive or negative whole numbers. So any positive or negative whole number, -4, -1, -27, and all the positive ones too. But then we have rational numbers inside here, and the rational ones are only positive. So all the counting numbers, like if you were to count something, so 0, 5, 24, whatever, any positive ones. So those are the properties of real numbers. A couple other properties we need to talk about are properties of addition and multiplication. If you want to go ahead and draw this table in your notes again, I think it'd be helpful. So on the left-hand column, we're going to write down all the properties. We have closure, the commutative property, the associative property, the identity property, and the inverse property. And then at the bottom, put distributive property. Alright, let's talk about closure. Each of these properties have different notation for addition and multiplication. That's why there's two different columns. Closure means In all of these, if you want to make a note, when I use A, B, and C, these are all real numbers. So instead of writing numbers, I'm going to write A, B, C, basically. Closure says if you add two real numbers, so if I add two real numbers, whatever they are, I'm just going to use A and B, because it could be 4 and 7, 2 and 8, it doesn't matter what number. So I'm just going to make it a letter to stand for the number. So if you add two real numbers, when you add them, they're still real numbers. Same thing with multiplication. If you multiply them, it's still going to be a real number. The commutative property says that if you add two real numbers, so A plus B, whatever, 2 plus 7, 4 plus 28, doesn't matter what they are, A plus B, you can flip them around and write B plus A, and you're going to get the same answer. Same thing if you multiply. If you had A times B, it's the same thing as B times A. If you want a specific example, it's like if you had 2 times 7, it's the same thing as 7 times 2. Same thing, that's all it's saying. The associative property basically says you can move your parentheses. You can move which ones you add first. So on this side, if I have the parentheses around A plus B, if I move them to B plus C, I'm going to get the same answer either way. It doesn't matter. Same with multiplication. If I have A times B times C on both sides, on this side I have parentheses on A and B, over here on B and C, I'm going to get the same answer. The identity property, in addition, says that you can add a 0 and you're going to get the same answer. So if you have 1 plus 0, you're going to get 1 still. So the identity of multiplication, you want to think about, if I have some number, what do I multiply to get that same number? So if I had 8, what do I have to multiply by to get 8? We multiply by 1. So anything times 1 is still itself. That's the identity property. In the inverse property, you're trying to get to the identity. So in addition, our identity was 0. In multiplication, our identity was 1. So if we look at the inverse in addition, we're trying to get to 0. So what do I add to A to get 0? Think about if you had 1, what do you add to 1 to get 0? Well, you would add negative 1. You would add just the negative A. Over multiplication, if you had A, and you're trying to get to the identity, and our identity in multiplication is 1, what do you multiply by to get 1? Well, you'd have to multiply by the reciprocal, so 1 over A. The last property is the distributive property, and it's the same for both addition and multiplication, because it uses both. And it just says if you have some number on the outside of a quantity, you can distribute it. So those are the properties across addition and multiplication. So let's identify some properties. The first one, we have 7 plus 4 equals 4 plus 7. We want to know what property does it say that you can flip the numbers around in addition. If you look back in your chart, you should see that it's the commutative property. You can flip the numbers around. It doesn't matter what order you have them in, it still comes out to the same answer. So your property is the commutative property of addition, because we're talking about addition. So on this one, we have 13 times 1 over 13 gives us 1. So if you look back to your chart and look to what property talks about getting a 1 in the end, and you're multiplying, so you're going to look in the multiplication column over here, and you'll see that it's the inverse property. You multiply by the reciprocal, and that gives you 1. So this is the inverse property of multiplication, because we're talking about multiplication. Alright, two other properties, and then we're done with these properties. We'll talk about what an opposite or an additive inverse is. They're the same thing. They'll either say opposite or additive inverse. The additive gives you a clue that we're talking about addition. here. All it says is that if you have some number A, let's call it, the opposite of that number is just the negative. So if you had 7, the opposite of 7 is -7. That's all it's saying. And with the reciprocal, or the multiplicative inverse, is talking about the same kind of concept except with multiplication. So if you have some number, the reciprocal is 1 over that number. So if you had used 7 again, if we're talking about multiplication, the reciprocal is 1 over 7. The next thing I have is talking about unit analysis. These problems use the units to figure out the solution to the problem. So on all of these, you want to keep your units with your number. So for this first one, it says you work 4 hours and earn $36. What is your earning rate? So to find our earning rate would be dollars per hour. So if you have dollars per hour, you want dollars on the top and per 4 hours. So when you simplify, your earning rate is $9 per hour. I want you to do this one in your notes, same kind of concept. If you travel 2.5 hours at 50 miles per hour, how far do you go? The other one we'll put in your notes is you drive 45 miles per hour. What is your speed in feet per second? So it gives you miles per hour, and you have to make it so your answer is in feet per second. So first, starting out here, you're going 45 miles per 1 hour. We're trying to get to feet per second. So you're going to multiply by, we need to take this hour, let's start there and make it into seconds. So we're going to take the hour, and before we can make it seconds, we have to make it minutes. So how many minutes are in an hour? There's 60 minutes. Then you can take the minutes and make it into seconds. So then we know that there's 60 seconds in 1 minute. Now the reason we keep the units on here is because you might be confused, well, how did I know to put 1 over 60 and not 60 over 1? Well, in the end, we want our answer to be feet per second. So I don't want any minutes or hours or miles in my answer. So in the end, my minutes should cancel out, and the only way they're going to cancel is if one's on top and one is on bottom. So I have to put my minutes on the top. The only thing we have left is we need to change this miles into feet. So you have to know how many feet are in a mile, and if not, look it up. There's 5,280 feet in 1 mile. And again, I keep the units on because in the end, I don't want miles, they have to cancel out, and the only way that's going to happen is if one is on the top and one is on the bottom. So I cancel out all my common units, so my miles cancel, my hours cancel out, my minutes cancel, and I'm left with feet per second, which is what I wanted. So then I can multiply straight across and get my answer. So if I multiply 45 times 1 times 5,280, and then divide by 60 times 60, I should end up with 66, not 60, feet per second. And that is your answer.